Let me now show you the simulation of the buck boost converter that we have discussed. I'll go into the work directory. There I have kept a folder buckboo, and within that, as usual, I have the .cir file, the .netlist file, the schematic file, and the subcircuit file. So if I double click and open the schematic file in GSM, the buck boost converter is as shown here like this. This is the switch, the control switch, the inductance coming in between here, the diode in this fashion, the capacitor charges up like this, you will get a negative voltage at V0. And you have a PWM block which will give the switching pulses to this control switch. The subcircuits for this control switch and the PWM block are placed within this file edt01.sub. Let us now simulate this. First generate the netlist and then simulate it. Let us open the command window and let me type in the command for generating the netlist. I am using gnetlist command and generating buckboo.net from buckboo.sch. This is the schematic file we just now saw. So when you do that, so on executing, you will see that the netlist gets generated. So the netlist is here. We have the netlist, and now you enter the ngSpice environment, ngSpice buckboost.cir, and it will execute and show the waveforms. So in the meantime, if I double click on the .cir file, you will see something similar to what we had written for the buck converter and the boost converter. It is a transient analysis which includes the buck boost netlist. And in the control statement, as usual, I am having background as light, foreground as black, running the transient analysis and plotting the inductor current. This is my starting plot. So this is the inductor current where somewhere around towards the end here near 100 milliseconds, you see steady state being reached. And I can actually zoom in there and see the inductor current. So this is the inductor current. As usual, I have given 75% duty cycle and 25% of the time of the switching period when the switch is off and the inductor is freewheeling into the output. Let me now plot the input voltage or the supply voltage, which is VA. As you can see from the circuit, the node A is that of the supply voltage, the node O is that of the output voltage. Let us see these two voltages in relation to each other, and therefore I will plot VA and V0. So plotting these two here, you see the red plot is VA, the supply voltage, which is at 12 volts, and the blue plot which you are seeing here is the output voltage, and as expected the output voltage is negative because the input output relationship is -D by 1 - D.